how does trauma create alterations in dopamine and the amygdala? I know trauma can shrink the hippocampus and enlarge the amygdala, which then can make us, right, like more hypersensitive, that kind of thing. But can you speak a little bit more about how it does alter the brain going through something like a pandemic together, or like you said, like a car accident, or, whatever, something along those lines? Can you be a little more specific for us?
Yeah, I've dived real deep into this literature. And so when you're actually looking at, neuroimaging, right, you've got these different techniques. There's, different types of MRI, functional, structural, there's PET scans, there's, volumetric based ways of measuring changes in the brain. And so there's no real obvious way. I mean, these are expensive things to do, right? So when you do this kind of research, let's say, I mean, when you look at PET scan stuff, we've got like N of 30, okay? It's not like they're able to do these longitudinal cohorts where they're following people exposed and doing PET scans every 6 months for 10 years. Like those studies don't exist, right? So what you're getting is, yes, you can do some follow-up studies and show that there are, in fact, a lot of changes in the brain, but some of the findings do differ, and the reasons is because there's a lot of other things that also affect the brain. It's really hard to control for social context, right? And so, for example, if poverty is associated with adverse childhood experiences, how do you know if there's changes in the brain if it was directly from the adverse childhood experiences or is from other forms of undernourishment or deprivation, etc. So we need to be real careful about saying really strong things about some of the morphological changes in the brain. But for example, something like the hippocampus has been investigated for lots of years and lots of studies, enough to actually meet systematic review and meta-analysis. And it makes sense from a trauma standpoint if the hippocampus is associated with memories. Okay. A lot of times people that are exposed to trauma are going to have, some adaptations that occur in the brain where they're going to not want to remember that. Okay. It's not promoting survival to be focused on that. So there's ways in which information can become encoded in the hippocampus and the amygdala. And so, yes, people that have trauma can have disruptions in their memory. But again, do we know that like the direct effect of trauma caused it, or is it because they couldn't sleep good? Because trauma made their sleep terrible, right? And so a lot of the data still needs more, nuance, etc. But yes, we know at the associational level that trauma relates to a lot of brain changes. The most pronounced is decreased hippocampal volume. The amygdala research is mixed. And there are some data that it's not. So it's another example of when you lump things together. When you look at the entire amygdala, yes, in some cases, the amygdala is enlarged, which is a part of the brain responsible for emotional reactivity, things like anxiety, depression, cravings, etc. That would track behaviorally based on what we know about trauma. But the research still is like trying to tease out like specific regions of the amygdala, right? Like it depends on how you measure it. Like, there's different sides of it, etc. So that it's a really hot stuff. And I'll tell you, like I saw once at a conference presentation, like if you really want to wow people and get them to really believe what you're saying, is like throw up an image of the brain from a scan, and they're like, okay, this is it, right? Like there's nothing higher than this, because most people, I can't afford that kind of research. You know what I mean? $2,000 a scan, right? Like I want to do that kind of research. I'm not even able to at this point in my career. So yes, super important stuff. But as we end all good research papers, more research is needed. Yeah, with the dopamine stuff, that's definitely been getting my attention, right? We know that adversity affects the way people respond to rewards. We've seen blunted dopamine transmissions. and we've seen alterations in the ventral striatum, which is, a big part of the reward centers, where a lot of the dopamine neurotransmission occurs. So yeah, people are more likely to have addictions, period. People that are exposed to trauma are more likely to have addictions. And that's been well established in the drug and alcohol world. And now, fast forward, it makes total sense why that would actually be true for the food addiction world. If there's neurobiological overlaps between drugs and alcohol and highly palatable food, if trauma predicts drug and alcohol addiction, guess what? Trauma predicts food addiction. And now we have a handful of studies to show, some in really large data sets. It really can't be ignored at this point. I guess the next question is like, so what do we do about it, right?